everyone. Thank you for joining our call today. It's been a while, but it's good to see all of you here again. And Maxim, I think you can just go for it with the presentation.
Yes, hi everybody. We have some pause for several weeks, and now we continue our developer calls. The last presentation that we had was devoted to the roadmap of RGB development and finalization. And those of you who has participated in it probably recall that one of the last bits that remained to complete RGB and get it into production was a thing called Bifrost. And this thing was crucial for RGB into Lightning integration and overall RGB functionality in Lightning Network. And today I would like to devote this call to this Bifrost thing, which is slightly more generic, or not even slightly, which is much more generic than just RGB related story. It's actually an upgrade to the Lightning Network itself, an upgrade which enables things which RGB requires, but also additional to RGB brings a lot of other stuff. And my purpose of this presentation is to give the introduction into what Bifrost is and describe the initial design and work in progress. Briefly, how we came to the idea of Bifrost. During our work on RGB, it became apparent that some of important functionality for RGB Lightning Network in fact, breaks with existing Lightning Network standards they named BOLT. Specifically, BOLT unfortunately doesn't provide a way how we can add additional feature flags as a part of BOLT 9, other than getting all the review committee and all the maintainers of Lightning RFCs to agree upon them, which from the experience of previous projects takes many months and sometimes years. So it was a very painful way, and that's why we looked into other options. And in general, we found out that Lightning specs, which are bolts, are really hard to update. And even though, even if we were able to update, their structure is done in a way that it makes hard to add new functionality into the Lightning Network. The second problem that we met was that even without Lightning Network changes, RGB itself requires certain data propagation. The clients of RGB has to send the client-validated data pieces over some certain P2P network. And it was a logical idea that we can leverage Lightning Network as a data propagation P2P network. Again, this had required changes to the standards, and we already discussed why it's very painful and long route. So we decided to create a generalization of Lightning Network, and we named that generalization Bifrost. Very briefly, the problem with both specifications, this slide I already showed on many conferences, and it comes from Christian Becker, who is the Lightning developer, that if we will layerize the Lightning Network protocols, we will see that existing BOLT standards, they lie very randomly on top of this structure. And that's why when you need to introduce a new piece of functionality, in many times you have to change multiple standards, and it makes it really hard with these poorly structured standards to propose new features. Even if you will be able to get into the standards, you will end up with a complexity of implementation, because when some certain Lightning node has to implement a single feature, it has to dig through multiple standards in multiple places and try to guess how they are related to each other. And as I said, it takes nearly forever to get pull requests to existing Lightning standards reviewed. It wasn't only problems with the standards that were keeping us frustrated with the attempts that we had on changing the Lightning Network. The problem is that transaction and message structuring of Lightning Network is custom tailored for two-peer payments, and basically it is a payment network based purely on HTLCs. And at the moment, when you try to add additional non-payment specific operations or even payment operations which are not well fit into HTLC and existing transaction structure, channel transaction structure, it was really hard or nearly impossible to do that. So for instance, no key tweaking, which is heavily used by RGB and client-side validation, is possible without breaking many standards. And it is extremely complex to change the structure of transaction, adding new inputs, and so on and so forth. Because just literally, if you will change one piece of transaction, you have to update nearly all of the bold standards. And finally, the encoding that is used by Lightning Network is not very well matching the guidelines we have developed for client-side validation applications, which we described as a part of strict encoding standard or LNPBP 7. So, the problem with Lightning Network doesn't only relate to the RGB. There is a lot of things that has to find its way into Lightning Network in the very near future. Unfortunately, while time passes by, these highly expected and long-awaited features are still not there. So this slide I was showing on the Lightning conference 2 years ago already, and this exact same form of the slide remains actual, and with only one exclusion. The first point, which is dually funded channels, is finally got its way into the Lightning Network 2 years after. All the rest, like channel factories, channel splits, short signatures, taproot, payment points, or other updates, they're still pending, and they will probably be pending for many, many more years. And additionally to RGB, there is a number of other proposals for interesting applications on top of Lightning Network, which were never being implemented or experimented with because of the complexity of the standard modification, because of the complexity of modification of existing Lightning node implementation code, and so on and so forth. So the Bifrost ideology is that we have to unlock the potential of Lightning Network to evolve and to build a layer 3 applications on top of this Lightning Network. And we would like to reiterate on the original idea of reckless development, which was part of the Lightning Network story. And we would like to rebuild a foundation in the Lightning Network for fast experimentation and feature extension. And we call the Bifrost attempt a reckless square. And we would like to create this Bifrost thing in such a way that it will require no changes to existing bold standards. It will not affect anyhow existing Lightning Network. It doesn't require the modification of other Lightning nodes to operate. Well, of course, it will be nice to have them supporting Bifrost, but initially we can start experimenting without any of them starting doing that. And we would like to separate risks of the new experimental protocol from more stable and already stabilized part of the Lightning Network put into production. And for that, we need a clear layerization and abstraction. I will start with the idea how we will put Bifrost into the context of existing Lightning Network and definition, more formal definitions of what Bifrost is. But before doing that, I would like to quickly check that the connectivity is fine.
Yes, everything is good.
So it's better than it was before.
Yeah.
Okay, perfect. So, defining Bifrost. You already, those who participated in our calls already familiar with the concept of LNP, which is Lightning Networking Protocol. The idea of LNP comes from this acronym LNPBP, which is similar to TCP/IP, denoting that the whole Bitcoin ecosystem, consisting of Lightning Network Protocol and Bitcoin Protocol, is a kind of new financial internet and a new type of internet protocols that unlock completely new level of the same values that original internet protocols had: decentralization, censorship resistance, privacy, and so on and so forth. Well, the original internet hadn't had privacy as a core value, but with LNPBP we do have. And LNP is the Lightning part of this thing. And LNP actually encompasses everything that exists today with a Lightning network or that can be built with a Lightning network in the future. So it's more generic than the Lightning network as it is described by bolts, and it includes all the bolt standards and existing and operating Lightning network. And next to it, we would like to put a Bifrost, which will be defined as a set of LNPBP standards maintained by LNPBP Association, which actually I'm presenting from today. And this Bifrost will be a second part of the LNP family of protocols next to the legacy Lightning network. So from now, I will be calling the Lightning network as it operates today and defined in bolts as a legacy Lightning network to denote with the rest of the story. And what these two things include: the legacy Lightning network versus the Bifrost upgrade of the Lightning network. The legacy Lightning network today is about only single or dually funded payment channels. So you can't have payment factories or channel factories, multi-peer channels, and many, many other things. It's just about a single or dually funded payment channels. It uses gossip-based route exploration and doesn't use any other proposed algorithms for more efficient and fast route exploration. It is based on HTLC payment propagation. And again, it doesn't include any option to use other mechanism like the proposed pay to elliptic curve point smart contracts. And it uses payment-specific onion routing based on Sphinx protocol. And this onion routing is really can work only for payments. You can't use it for sending arbitrary data. The Bifrost, on the other hand, is designed as a pure networking protocol. It separates the concept of channel and payments from the concept of networking and addresses only networking, abstracting all channel, payment, and other applications on the levels above. And in terms of networking, it creates a general data propagation peer-to-peer network that can be leveraged by many applications, again, not just payment related and not even just state channel related, but for instance, in arbitrary data storage networks. When it comes to the state channels, it can operate multiple and even nested channel of different sorts and kinds, and all the business functionality of this channel is defined on the levels on top of Bifrost network, and Bifrost is abstracted from specific channel functionality, meaning that adding new channel types or updating their features will not require any changes to the Bifrost protocol itself. And more even, it allows a channel composability when one channels can be constructed out of other channels, like a channel factory can be used to construct a normal bidirected funded payment channel. And from that payment channel, into that payment channel, you can embed, for instance, a DLC, discrete log contract-based channel. So you can compose channels on top of each other. I will be demonstrating in more details how it will work a bit later. And the way we will put it into the Lightning network is that we will do a new sub-network of the Lightning network operating on a different port number, let's say 9999. And it will still leverage the part of existing Bolt standards specific to the session management, which is Bolt 8. And we have split actually Bolt 8 into two standards, defining the encoding and encryption based on noise HK and the message format. So it is still the same Bolt 8 functionality, fully interoperable with the Lightning Network, but just more clearly separated between layers. And we will have a way how two Lightning nodes connected over the Lightning Network can exchange a message to start an upgrade process and open a separate Bifrost connection over this special Bifrost number. Also, there will be a special dedicated feature flag that will allow Lightning nodes to signal their support to Bifrost protocol, such that they will be able to open the Bifrost connections to each other without even using Lightning Network signaling. So this is more specific slide about how the different standards are put in context of LNP, Legacy Lightning Network, and Bifrost. Both Legacy Lightning Network and Bifrost, as I already said, works on a session level management protocol called Brontite. It's the name that is used by the Lightning Network, so it's not a new protocol. It is defined as Bolt 8 standard or LNPBP 15 and 18 standards. The Legacy Lightning Network, on top of that, puts a standard for how messages are actually structured and a control protocol with the messages between the nodes. It's called Bolt 1. And on top of that, there is a number of different protocols, how the payment channel transactions should be structured and handled, how HTLC payments should propagate, and how the network topology has to be monitored with the gossip and routing protocols described as Bolt 7. Unlike this, Bifrost have a slightly different structure. It replaces Bolt 1 for messages with a new standard called LNPBP 50. And the standard defines a different encoding for message, a different structure of the message, and a different set of control messages. On top of Bifrost itself, there will be extension protocols, one per specific channel type or application type, which will work on top of Bifrost, and Bifrost will not be aware of these protocols. It will be completely blind to their functionality. So Bifrost is a pure network level protocol, abstracting away channel-specific functionality into application level above. This solves one of the main issues with the design of the modern Lightning Network, where to introduce a new functionality, like do a bidirectional payment channels or use TypeScript in Lightning Network, you have to rewrite and amend all existing Bolt standards. With a Bifrost, it is not required because it will not affect the core of the protocol, and it will be just another application on top of the Bifrost network. For those who are interested even in more technical details, this is the way how we see the layerization of the whole LNP protocol stack, including both the legacy Lightning Network. The legacy Lightning Network is present in the left part of this chart in yellow color, and Bifrost network, which is shown, Bifrost specific parts are shown in green. Also, this all works on the TCP/IP Internet Protocol stack, and it uses TCP as a transport protocol, on top of which we may have a session encryption level 1, either built of VPN or IPsec protocol or Tor version 3. We will not be using Onion version 2 addresses because of the vulnerabilities like recently discovered. So these are optional encryption protocols that can be sticked between TCP/IP and Lightning layers. On top of that, the base layer of the Lightning Network is a session management and encryption protocol called as I just said, I forgot this name, Brontite, and defined in Bolt 8. Also, Bolt 8 in the second part defines a message framing protocol, which is also used by both Bifrost and Legacy Lightning networks. Starting from this layer, Bifrost and Legacy Lightning networks become different. We use different connection protocol. And in case of Bifrost, it's namely Bifrost, defined as LNPBP 50. And on top of that protocols, we have a set of protocols for working with a network topology. This is a network topology application level protocols. And for Bifrost, we will not use a gossiping mechanism like it was used in Bolt 7. We will use more efficient forms of routing. Specifically, it may be an ANT routing, which is a good proposal several years ago, improving the through output of the Lightning Network by not requiring the gossiping that should be delivered to all nodes about the topology of the network. Because with the growth of the network, you have a significant increase in the amount of the gossip messages that has to be forwarded. And we would like to avoid that. And also we will use a modified version of Bolt 4 for the onion routing based on Sphinx protocol. Why we would like to modify it's because the Bolt 4 defines onion routing only for payments, while we would like to have onion routing for arbitrary message types. And basing on these two routing protocols, there will be an application level, which in case of legacy Lightning Network is only payment applications defined in 9, 2, and 4 bolts. In case of Bifrost, it could be multiple different applications like RGB, the PTLC-based payments, L2, and so on and so forth. So, as I already said, Bifrost abstracts the channels away to the application level, and payment functionality also to the application level. And that makes Bifrost a perfect generic P2P data network that can be used for messaging. And such a network, in fact, will leverage the privacy of Sphinx protocol for onion routing and anonymity of addresses composed of the Lightning node public keys, and also underlying to onion addresses if they are used. And in this regard, you will have a perfect end-to-end encrypted messaging system inside decentralized network. There are already attempts to do that on top of legacy Lightning, and there is even a pull request which is being reviewed for about a year so far. Maybe it will be merged one day. However, that messaging pull request is very specific to chat applications, while we would like to have a more generic messaging enabled in the Bifrost protocol. Also, it is quite important to link the messaging to the payments, which again can be done at the application level. And we already have a native currency of the internet, Bitcoin, as a part of the Lightning Network itself. The second main area of applications of Bifrost as a generic P2P data network is, of course, information storage and information retrieval network. And in that terms, we can have a prepaid information storage used for storing the channel state, used to store RGB consignments, those parts of the client validated data that has to be sent over during the RGB smart contract execution. It also may store such public RGB contract information as asset information from issuers or media resources for NFTs, and even generic files and information in a torrent-like way, but paid with Bitcoin. Also, this information storage and retrieval network can be reused for building watchtowers, and you can combine it with a custom channels called Storm, which we have proposed several years ago for long-term trustless information storage contracts. So all of that can be put on top of Bifrost as an applications, and actually independent developers can create applications using those, providing those functionality to the end users without any changes to Bifrost, as already said. So in fact, Bifrost may be considered as a future platform for social networks, which can be censorship resistant, private, and incentivized with Bitcoin payments natively. Of course, additionally to that, because Bifrost is not just a Bitcoin-based network, but it also works with RGB and other forms of smart contracts possible on Bitcoin, we see Bifrost as a BFI platform. The term BFI stands for Bitcoin Finance, or even Bifrost Finance. And we have discussed a lot of BFI applications on the previous 2 calls devoted to RGB. You can dig into that. We were describing how you can build DEX and how you can build liquidity pools, how you can do many interesting smart contracts using just pure Bitcoin Lightning Network and RGB without anything from the Ethereum world. And that's why we believe that Bifrost will be the platform for BFI applications as well. So that's all for the definition part of the Bifrost, what it does and how it works. And now I would like to dig into more details about how Bifrost structured internally. But before that, I would like to check with the audience that there is no questions for the first part.
Guys, are there any questions right now? If you do have some, just speak up. Probably no questions for now.
Okay, I will proceed. The design goals which we had in mind for doing Bifrost and which we were checking all the time, the design of the protocol against those goals is there are main 3 goals: extensibility, maximum leveraging of existing standards, and privacy. As for extensibility, we would like Bifrost to be able to host such applications as non-payment applications and custom Lightning channels, non-payment network messaging, communications, and data storage, arbitrary extension of channel transaction structure, where you can combine different types of channels, compose them together, and add on top of each other, and custom and URL discovery mechanisms. So Bifrost should support all of that. As for existing standards, here is on the slide, you have the list of the standards which are used by Bifrost, so it doesn't change them. And actually, it allows us to simplify the Bifrost specification by itself, because many things that are actually Lightning Network, part of the Lightning Network standards, or the same body of the standard, like data encoding and so on and so forth. Here they are separate standards already used in other protocols outside of the Bifrost itself. And finally, for the privacy, we are looking forward to improve the onion messaging, that's Sphinx protocol from Lightning Network. And the design of the Bifrost, we will start with discussing how we are going to abstract different channel types. And I have to say that it was one of the hardest parts of the Bifrost design, because basically there is a lot of things that you can do with the state channels, and there is a lot of ways how you can compose them with each other. So we found something that we think is realistic and reasonable. And again, I would like to invite as many interested people into discussion on this design. So what type of channels there can be overall, not just in existing Lightning Network, but everything that we can imagine that can be put into the state channel on the Bitcoin. Of course, first of all, it's a normal Lightning payment channels, which are defined in standards bolt 2 and 3, with existing features that already added there. There is a lot of improvements that came to the Lightning Network. They are pretty much simple improvements, like ability to specify custom scripts for the closing transactions, or improving the mechanisms of fee in the channel transactions, or having a dual funded channel. So basically, these are very small improvements to the B-party payment channels. But also, you can think about more extensions to existing Lightning payment channels, like allowing RGB, allowing channel splits and joins, adding taproot support, miniscript, and maybe one day L2 after the proper soft fork in Bitcoin network. And these changes are long pending, especially channel splits, but unfortunately there is no ongoing work in the Lightning network on them, but we would like to have them as well. Additionally to normal Lightning payment channels, there is many other types of channels we can think about. First of all, these are channel factories or multi-peer channels where multiple nodes can construct a single channel, out of which new channels can be created. Another type of channels is a discrete log contracts, which are actually enter with the taproot, they enter and adapter signatures, not taproot, with the snore signatures and adapter signatures, they enter a production space. And discrete log contracts by themselves are a form of state channels because a number of transactions, pre-signed transactions, are kept outside of Bitcoin network, unpublished, and depending on the result, or partially signed, and depending on the result of the future price, the discrete log contract fulfilled and the channel is closed. So basically DLCs are by themselves a form of non-payment smart contracts in the form of state channels. And they should be natively supported by the same network that operates other state channel types. I already mentioned a Storm, which is incentivized storage type of smart contracts, and Storm is also built as a form of state channel by itself, because you have some transaction that is mined and the rest of transactions originating from that transaction kept off-chain for a long period of time. So this is a form of state channel. There is other protocols I haven't mentioned here, Prometheus, which acts the same way as Storm, but for computing, decentralized computing, and Lightspeed, which is ultra-fast multi-asset nano payment. It's a modification to existing Lightning network, which can leverage the higher speed and less signatures to do much more faster payments. And many, many others, I believe, will appear soon. Many more types of channels can be created with this core concept of keeping pre-signed transactions off-chain and publishing them depending on certain circumstances. So these different forms of channels can be built into a hierarchy. And each channel starts with a funding transaction. And the base funding transaction should be mined into Bitcoin blockchain. And using that funding transaction, you create some channel type. On top of that channel type, you can create another channel, and you can put the funding transaction as a part of the channel on the level 1. And you can compose channels on top of channels in that way quite a lot. Important to remember that additionally to the pre-signed transactions inside the channel, we also have a thing that's called ephemeral state, which is not a part of the transaction, and which should be kept as information about the channel state by the node. Today, the Lightning nodes do not have unrecoverable ephemeral state. The only thing that can't be recovered are signatures on the channel transactions. But other types of channels, which we had discussed, may have also ephemeral state, also important to keep. So each channel is in fact starts with a funding transaction. And this funding transaction can be modified by channel updates. It's once and forever for this specific channel. Funding transaction is mined to Bitcoin blockchain for level 1 channels, or it is a part of other channel transaction graph for channels on the levels above 1. The channel by itself is represented by transaction graph. So this channel transaction is in fact not a single transaction, but most frequently a graph of transactions connected to each other. All of them are unpublished. And each individual channel has a separate transaction graph. Transactions from one channel may act as a funding transaction for other channels. And if some of the channels is closed, a closing transaction should be added to the channel above. Or if it, in case of level 1 channels, it should be mined into Bitcoin blockchain. So these are rules that we define for the abstraction of the channels from each other. These rules we will follow to construct the Bifrost abstraction mechanism from specific channel types. And let me show you how this can work in practice, which will be quite much more advanced than the existing Lightning network. Let's assume that we have a funding transaction, and this funding transaction will be a funding transaction for a channel factory. 3 nodes, represented here by names Alice, Bob, and Carol, would like to create a channel factory. And for that, they provide their inputs. And Alice, what Alice does, she actually provides 2 inputs instead of 1 input, because she has a different small amounts, and she would like to consolidate that. Today, with existing Lightning Network, this is not possible. In fact, Alice had to do a separate transaction consolidating those inputs and then use it to fund the channel. However, we think that we should allow such things as a custom inputs to the funding transaction. And the output, there is a single, the first output is actually the multi-sig 303, which creates this channel factory. But it could be a case that, for instance, Alice would like not to put all of the money into the channel, but leave some aside, and also Carol. So there should be an option to have a change outputs for Alice and Carol. So we already have quite a custom structure on the funding transaction. Using that factory, this funding transaction is mined into Bitcoin blockchain. And once it's mined, the nodes, the participants on the channel factory, open the first channel with the funding transaction for channel 1. They use the channel factory as an input, and they also create a channel funding output, and the second output that keeps the rest of the funds which were not used in the channel 1. These funds can be reused later by a second channel created from the same factory with pretty much the same structure. And on top of that, there should be always a closing transaction, returning funds, the remaining funds back to the Alice, Carol, and Bob. All of these transactions in yellow, cyan, and blue are not published to Bitcoin blockchains. They are part of the channel factory itself. And you see that the funding transactions for channels are part of the channel factory and not the specific channel 1, channel 2. That's what I was saying on the previous slide. Now, if we will look into the structure of the channel 1, we will see that it is composed, it originates from the channel funding output, and it is composed of the commitment transaction and a set of HTLC transaction, like a normal Lightning channel. However, additionally to that, we would like to allow such things as adding other types of contracts. Additional to HTLC, here we have a PTLC outputs, and this channel will be able to operate and route payments, which happens with both HTLC and PTLC, in both HTLC and PTLC format. And finally, we would like to be able to embed a DLC channel into the channel 1. And this DLC channel will operate using the commitment transaction as a funding input. And here, at the end of the day, what we have is, in fact, 4 channels. The channel factory, channel 0, 3 normal Lightning channels, and DLC channel on top of Lightning channel. So that's the stuff we would like to allow to be done with a Bifrost. You see the composability of channels, different types of channels, the custom transaction of specific, the custom structure of specific transaction inside the channel. All of these 3 things are impossible with the modern Lightning network and will require years and years of modification of existing bolts, affecting nearly each part of the standards for the Lightning network. With the Bifrost, we are trying to abstract that away. The side cost of this abstraction is that generalization of channels will require nodes to keep not just transaction signatures, but full transaction structure, because each channel and each transaction in the channel may have a custom structure, not deterministic, unlike existing Lightning network. So how this custom transaction structure can be negotiated between Lightning nodes? We propose a thing that we call a channel-based smart contract proposals, which actually a way to structure information about this complex transaction graph into a single piece of data. It's a kind of PSBT-like data structures. PSBT are partially signed Bitcoin transactions used for on-chain transactions in hardware wallet world. Here, we do pretty much the same data structure, but slightly more evolved. These CSCPs will work as a template for transaction and channel transaction graphs. So they will contain not just a single transaction, but a graph of interconnected transactions. And these CSCPs can be contained within each other, allowing channel composability, as was shown on this slide. The node proposing this smart contract for a channel will sign this proposal with a node key, not with a key that is pending key for Bitcoin transaction, but with a key that is specific to the Lightning node. And that will help to negotiate the specific channel structure for multi-peer channels, where there are multiple interactive communication rounds should happen between 3 or more nodes. And this structure is limited to 64 kilobytes in size, which is fine because unlike the real transaction, in Lightning channel, you can have a transaction with thousands and thousands of outputs because of HTLCs. These are templates. So basically all these thousands of potential HTLC outputs are represented with a single output of template type that here HTLC goes. So 64 kilobytes is pretty much reasonable. And this requirement comes from the fact that this structure has to fit Lightning message size limits and also Alluvium registers, which I will be talking more about a bit later, how Alluvium is related to the Bifrost. So that's all about the way how we abstract the specific channel structure out of the communication protocol. The second thing I would like to describe is how we organize the typing of a message system used in Bifrost and changes to the encoding algorithms. I will start with encoding changes. First of all, we remove the support for big int type. What big int type is? Well, originally in Satoshi Nakamoto design of Bitcoin, he proposed the idea of variable length integers, where the same integer may be encoded with 1, 3, 5, and more bytes, depending on the value of the integer. That was created to preserve the space in Bitcoin blockchain, which is precious and was quite rational. Unfortunately, designers of Lightning Network, they followed the same idea, but they changed the standard from little endian encoding into big endian encoding, and they called it big int type. And it doesn't have a proper rationale because in the network communications, you don't have a need to preserve 1 or 2 bytes of the data. And still, even Lightning messages, they should be of the same size to maintain more privacy. So you will end up with the same 64 kilobyte messages, most of which will be unused. So this introduction of a big int type was very unfortunate one. And when we were designing the encoding for RGB, Peter Todd pointed out into this that we shouldn't follow such a design, and we created the standard which called strict encoding used in RGB itself, and it was designed specifically for client-side validation. With the Bifrost, we are just reusing this standard, which adds a lot of interoperability of the Bifrost with the RGB and with Alluvium. The last thing that we are not changing anything about TLVs other than we just replace big int where it is present there with a normal integer type. The next thing is a feature flags. the current, or how we call it, legacy Lightning Network, it uses standard Bolt 9, which defines a concept of a feature flag that signals support for new functionality inside the Lightning Network. The idea is quite beautiful. Unfortunately, in practice, it's not working that well as it was expected. And we ended up in a situation that whenever we need to introduce a new functionality into the Lightning Network, we have to get through the peer review of the Lightning Network standards, and we have to modify it basically Bolt 9, because it explicitly says that all the custom values are invalid and break the protocol. So this creates a narrow thing that it's really hard to penetrate whenever you would like to add something to the Lightning Network and experiment with a new functionality. So we don't want to follow the same pattern. And instead of Bolt 9 type of features, Bifrost will use strings and numbers for defining a standards describing new features. So there is an open set how you can name specific feature, and it is advised. The name is actually uppercase letters plus numbers plus dash, and you just specify the supported standards by certain node, and that would be the way of signaling it. Pretty much the same as it works in Bitcoin. And there is no specific set of the standards which supported. You can use basically any name, not just LNPBP standards. You can use beeps and bolts. You can use other sources of standards, so you can even create your own one. So you have no censorship on the introduction of new functionality and no requirements to modify the Bifrost protocol or the node to introduce, to understand and run a new standard. The next part I would like to talk about is interoperability of Bifrost with the existing infrastructure, how it will interact with the Lightning Network. Before moving to this part, maybe I will check once again. Are there any questions on the part 3 about the design of the Bifrost internals?
There was a question before. The question is are the new LNPBPs already written that you mentioned?
Yeah, I will be showing a slide with the references. There is a draft, the draft for Bifrost specification. It will be updated quite soon, but all your suggestions I will ask to put into these pull requests with a Bifrost standard definition.
Okay. There is also a comment. Maybe you see it on the comments if you open them.
No, I don't have. I don't see the comments.
Okay. The B1F1 hex is 45553 for the port number. That's us for the port number.
Just a second. I will go outside of the presenter mode and we'll try to check the B1F1 hex is 45553 deck for the port. Oh, okay, I see. It's a proposal for the port number standing for kind of Bifrost. Yeah, well, maybe. I was trying to keep it in the lower range, so before 32,000, like a Lightning Network, and quite close to the original Lightning Network port number. So, but we can put it as another option to have it 45553, which looks also nice.
Okay, so do we have any more questions, people? Yeah, probably not for now.
Okay, there is only 9 slides left, so I think it will take about. Go on.
Perfect. Yeah, we can go on.
No, somebody was talking, asking something.
That was me making some noise, probably.
Oh, okay, maybe. So interoperability. First of all, we would like to provide a way to upgrade existing connection between two Lightning nodes to Bifrost. And the way is going to work is that from now, before today, the Lightning nodes are always connected through the same port number, which is Lightning Network port, running the set of both protocols inside that connection. Bifrost will require a separate connection using a separate port number. There was some discussion that maybe we can reuse the same connection and the same port number, but the idea was that there will be many situations when two nodes have to maintain both legacy and Bifrost connection at the same time without them intermingling into each other, reducing the risks of potential attack surface or potential problems between the protocol and collisions between the protocols, because they use different encoding, and it will be really a nightmare to put this two different separate business logic into processing the same network connection. So the idea is to have a separate port and to allow both connections operating in the same time, because for a long time, even if Bifrost will be successful, many payments inside existing Lightning network will be routed through the legacy connection. And you don't want to lose those payments and routing function inside the legacy Lightning network. And you also would like to receive incentivization for Bifrost requests in Satoshis. And that's why you basically need both connections at the same time. So if you have a legacy connection in the Lightning network, the idea that you can add to that a Bifrost connection to any other node. So of course you can open a direct connection to other node if you know that it supports Bifrost and the node signals the support for Bifrost with a certain feature bit. So you know that ahead and you can open a direct connection. But let's assume that you are behind the NAT, or that you would like to connect to the node which IP or Tor address you don't know. You have just a node public key. And you can do that by sending a special onion payment where the last packet inside the payment has a very specific custom structure. It's basically a hack into existing Bolt standard. And this hack allows you to ask that node to open connection back to you using Bifrost, direct connection. You provide your Tor or IP address to that node, and that remote node, when it receives this request, it opens connection back to you by passing NAT. And that acts pretty much like a UDP pinhole, UDP hole punching technology. And I think that allows quite efficient establishment of the connections leveraging the existing Lightning Network topology. Another important point is that existing channels can be migrated to Bifrost. However, each channel should be either operated in the legacy network or inside Bifrost network using Bifrost messaging. Why? Because if you will allow a channel to be operated via two routes at the same time, you will have a lot of collisions. Specifically, if you will modify the channel structure via Bifrost, it will become incompatible with the legacy Lightning network, and it will basically break the whole story. So the channels can be created inside Bifrost originally, and the channels can be migrated from the legacy system into Bifrost. So if you today have some channel and you would like to migrate this existing channel into Bifrost, that will be possible, always possible. However, once you migrate this channel, you wouldn't be able to route the payments through this channel inside the legacy network. You will be able to use this channel only inside Bifrost. And when you will be doing this upgrade, there is a certain sequence of actions. You will announce to the old network that the channel has switched into use of Bifrost with a special required feature flag that will exclude this channel from the routing map and topology of the legacy Lightning network. and you will also announce this channel to the Bifrost. There is also sometimes a possibility to downgrade channels from Bifrost into legacy Lightning Network, but it only can happen if the channel the structure of channel is fully compatible to the bolt standard. So the channel was not modified, or even if it was modified, all modification has been removed. The use of RGB assets has been removed, the excessive outputs has been removed, and so on and so forth. And only after that, the channel can be downgraded back to the legacy network. Why we need this downgrade functionality? Well, basically because we expect that Bifrost will be really non-production ready for a long time. And if something will go wrong and there will be some issues and bugs and hacks discovered, we would like to give people ability to get their working channels and put them back into safe legacy Lightning Network. So that's the idea. It's the same slide. So it was about, the first part was about connection and the second part about channels. The next thing that changes is invoicing. To do a payment in Bifrost channel, the node must use a special new invoice type, which was defined in LNPBP 38. It's universal Bitcoin invoices. We had a presentation about them in the spring. They were developed as a part of RGB, but they were more general because this invoicing type, it supports both on-chain and Lightning transactions. It supports Bitcoin and other forms of RGB assets, or even potentially non-RGB assets. It allows you to structure Lightning payments in a way that if your Lightning node is offline, you can specify a fallback node, which will receive and hold payment for your node while you're offline. And this mechanism is actually, those days, was designed to use this future Bifrost, which we were already thinking of. So the LNPBP 838 universal Bitcoin invoices is the invoice format for Bifrost, and Vault 11 invoices will not work for it. The final part on the interoperability is the design of Bifrost URLs, which will be quite frequently used. Unfortunately, we had to change it from the design of Lightning Network URLs because Lightning Network URLs are not standard compatible with the RFC defining what URL is. And a Bifrost URL will start with a Bifrost keyword, of course, double dot, 2 slashes. Then we will have a node pub key as a required part, followed by optional node address. And the node pub key will be separated from node address using the plus sign. Why plus and not the at, as in the Lightning Network URLs today? So you know that today you can specify the address of Lightning node by putting the Lightning node pub the key, at sign, and then IP address or Tor address. We can't use at sign because it contradicts the RFC 3886 on URLs, and at sign can be put only between first optional part and the second required part. While here, the node pub key is the required part, first part, and the node address is in fact an optional part. So that's why we are using the plus sign, which is allowed to be used in this case. And then after the slash, you can additionally provide information about channel ID and different parameters. So the node address as of today Lightning Network can be in form of IPv6, IPv4 address, or Onion version 3 only address. Onion version 2 is not supported as a vulnerable address type, and optionally it can be followed in case of IP addresses with a custom port number. If the port is not provided, of course, we use the default port 9999, or which one will be decided later. And the parameters may be parameters that specify a route suggestion if the node address is not used, which will allow a node to connect to a remote node using only pub key without the need to download the whole network topology. or some specific channel configuration options which can be specific to different to particular channel type. Additionally to the form of address that allows to address the channels, we think that there will be also URLs for arbitrary data retrievals, which will use a 32-bit resource ID, a hash of the information data. And this will allow Bifrost to operate as a distributed resource storing network, as a better alternative to what IPFS, BitTorrent, and other projects does today, but with the ability to add an incentivization and payment in Satoshis to that. That's all on interoperability. And the final 2 slides is about the work in progress on the implementation of Bifrost, where it happens. Today, what we have is the Bifrost standard proposal, the LNPBP 50, which I told about. It doesn't contain few things from this presentation, which I will add tomorrow, but the rest of it is already quite detailed. And everybody is invited to go into this pull request and provide your suggestions, critiques, and so on. The actual code implementing Bifrost goes into LNPBP core library. It is right now in a separate branch, which can be accessed and reviewed using this pull request in the second bullet point. It does actually the implementation of the business logic and Bifrost specific data types. It's quite early days pull request, and there will be more work coming to it in the next several weeks. The node, the Lightning node that will be fully supporting Bifrost is LNP node that we are doing. As of today, there is no specific pull request. We will work on it in parallel with the LNP core implementation in the following next weeks. And there is yet not full with the tasks, but it will get more tasks soon. A Bifrost dedicated project on GitHub, which you see on the 4th bullet point. And the final note is about Bifrost extensibility, because it's designed as extensible protocol. And if today there will be a need to do a Bifrost-based custom applications, like we will be doing RGB as a Bifrost-based custom application, RGB over the Lightning, and also on-chain part of the RGB specific for the sending RGB consignments for payments, and also distributing the information about the assets and media files related to NFTs. So it will be used both in the RGB Lightning network and RGB on-chain. So these 2 applications will be done as a Rust code, which will be part of LNP core library. Other developers may write, not necessarily need to contribute the application to LNP core library. They can use they can write a separate library. The only thing that it should use LNP core library because it provides all Bifrost related data structures. And after that, there will be need to fork LNP node or create a custom binary for LNP node and add this application as a module to it. This is not very convenient. So this is the way it is done today only because we need to do things not in parallel but one by one. So we will finish the LNP node Bifrost RGB, and then we will move on working on Alluvium and more language, adding more support for more languages to Alluvium. The Alluvium is the virtual machine that we have created originally for RGB, but we were presenting it this summer together with the first language, which is Alluvium assembler, and the compiler and the linker. So they already exist. And our plans is that the same virtual machine will be used inside the Lightning node, LNP node, to run the business logic of channel. So if somebody will be developing a custom channel type in the future, for instance, for Storm or for channel factories, the only thing that they will need to is to define the business logic of this channel once using one of the languages that we will compile into Alluvium code. And then this code can be plugged into existing LNP node in a hot mode. So you don't need to recompile the node. You don't need to fork it. You just add another plugin to it. And you, by doing that, you can add support for new channel types into the LNP node. We would like to believe that maybe in the future, other Lightning node developers will also integrate LUV, which will unlock to them the same ability, such that the custom channel can be written once and used in all existing Lightning nodes. And basically, the definition of new channel types can be done even in code, because it will work in the same way on each node implementation. But I'm quite sure that this will not happen that soon, but at least there is some future to wait for and believe into. That's all for the introduction into the Bifrost development as of today, and we can move to the questions if there are any.
Wonderful. Thank you very much for the talk and for the slides for the presentation. So guys, questions?
Do we need Bifrost to be fully implemented before RGB can go live?
Not everything that I was describing today has to be implemented before RGB will go live. So we will start with the very core of the protocol. No custom channel types and everything like that, plus the features that are required by RGB. And this will unlock our ability to release RGB, after which we will turn back to the further enhancements to Bifrost protocol, which will unlock its potential. It's quite fortunate that unlike RGB itself, with the Bifrost, we don't have this restriction that once we do a release, we can't change in the future. No, Bifrost is like Lightning Network. We can add more and more functionality without breaking the consensus or anything like that.
Okay, thank you.
Next question. Will the number of different channel types become ever a problem? For example, must every node have channels in each types to use them?
No, there is no requirement that each node must open channels on all of the types. It's more up to the node maintainer which channel type he would like to support and which functionality he would like to provide to the network. Because for the most of the channels, there will be some incentivization like routing fees or data storage fees or other types of fees. So it will be user interest to open different forms of channels, but of course, each one may differentiate on some specific channel type they would like to work with.
Okay. Next one. I understood that it's going to be released at the end of the year. What is going to be released exactly? Sorry if it was said, but I lost the sound.
Well, as I said, it will be the very simple core version of Bifrost. So it will be Bifrost Core without any applications on top. So basically, the only thing that you will be able to do is pretty much the same as you can do with today Lightning Network, except the only two applications that will work is RGB specific applications for on-chain and Lightning RGB operations. And after that, we will be starting adding more channel types. And of course, we invite external companies and developers to work on more channel types. And basically, there is nothing to Bifrost than the core protocol. Everything else is an extension and application on top of that. So we will release the core of Bifrost protocol, but the main value will come from the applications on top of that. And we expect that it will be not only us who will be developing those applications. In fact, we are giving tool to the developers to experiment with the stuff they would like to experiment for a long time, like channel factories, channel splits, adding DLCs, and many adding taproot support, and many other things, without all those problems that they had before, requiring the pull request to Bolt repository or refactoring of the whole architecture of the Lightning node.
Okay, I think we can move to the next one meanwhile. Yeah, okay, got it. As a not hardcore developer, it's difficult to imagine the use cases. Could we start a brainstorm with some people what kind of dreams we'll accomplish? You mean with Bifrost or with RGB?
Well, Bifrost and also RGB, maybe the combination. What will we build next year? What kind of applications will be there?
I think we cannot say what kind of applications will exactly be built because, I mean, we're not doing all of the applications that can potentially be built there. And the use cases are written and described on the FAQ website.
The basic idea that you should be able to do everything that can be done with Ethereum today, like DeFi thing, so any kind of type of DeFi smart contract, but with a Lightning Network and RGB. So that's the core idea of Bifrost and RGB, to bring the DeFi into Bitcoin world with the full potential, and even better because it will be more scalable, unlike in Ethereum. You're using Lightning Network scalability for that. You have it will be more private because Lightning Network is more private, and RGB as a client-side validated technology also brings quite extreme privacy, and it will be less censorship resistant and more decentralized, and with Bitcoin. So that's the imagination, high-level imagination and vision that we have and try to implement.
Okay, thanks.
The next, other working examples of some RGB operations over Bifrost. Can I work my way to make some RGB transfers in Bifrost with the code published now?
No, because the Bifrost itself is the work in progress, so we have to finish Bifrost there, and then we will have some RGB applications on top of Bifrost. So it's very early days of Bifrost design, and the call today is not the presentation of something that is working. It's rather the beginning of the discussion while the protocol is being implemented to maybe somebody will notice some way to improve it further or some vulnerabilities or something like that. So that's the purpose.
Okay, so more questions, people. How will nodes be incentivized to store Bifrost data?
Well, basically, there are several ways. The most simple way, there will be a prepaid storage. So you ask Bifrost node to store some data for you, and you provide the Bifrost node with a payment in Satoshi using just normal Lightning Network payment. And in this case, this can be used, for instance, when you need to store the state of your channel, backups of your channel, backups of RGB data, or you would like to store some pieces of your information from your machine, even as a form of backup. Of course, you have a risk that the node will not actually keep this data. And here the reputation system will work. Basically, wouldn't ask those who are not trusted to keep the data further. So, and you will basically pay to multiple Bifrost nodes such that if somebody deleted your data, you always have other backups available. This is the most simple but most risky way. The more advanced way is that you use the Storm channels which are specifically designed to address this risk problem. And with the Storm, which is quite advanced protocol, you can be sure there is a double stake. So there is a stake that the node that keeps your data puts, and that if your data are lost, you are paid back with the stake of that node. And again, your data are lost, but at least you can reduce the number of nodes that keep your data and have a good compensation if the data are lost. So it's more advanced form of contract. And of course, there could be a data which of public interest, for instance, information about RGB assets, or some NFTs of public interest, or just generic information like information from the Wikipedia. And the Bifrost nodes, they can keep this data and index them locally, and other node can query that data and pay per query. So they will be keeping data without being paid upfront, but because they know that people need this data and query this data frequently, they can be sure that they will monetize the storage of the data with the queries coming. And the queries will be paid with the Satoshis once again. So for instance, if I'm a wallet and I would like to know which RGB assets exist in the world, I will ask some Bifrost node that I like to, I will pay some Satoshis to it, and I will get the whole list of the assets in the network. So that's the way it can work. So these are three main scenarios. Yeah, and all these scenarios are incentivized by payment in Satoshis, or even in RGB stablecoins or something like that.
Okay. And I see this very potentially revolutionizing, like a World Wide Web, but much more private.
Well, hopefully, still a lot of work ahead, but maybe with so in several years we will see that this thing will really change something in the landscape of the internet.
Maxim, can you differentiate once more? So Bifrost is not the same thing that the generalized Lightning Network protocol that we used to talk about and presented, right?
Well, I think that's a better name for generalized Lightning Network protocol. So again, I'm showing this slide. Mm-hmm. The core idea is that everything that is not existing in the Lightning Network today, we call the layer to add anything that is not existing in the Lightning Network today, we call it Bifrost. So if it's not a Lightning Network today, then it is Bifrost or something built on top of Bifrost as an application.
Mm-hmm. Okay, got it.
And before, in the previous presentation, we were talking about that as a generalization of the Lightning Network.
Yeah, but we didn't.
The idea was that we will use existing Lightning Network and add functionality to it, and we will call that generalization. The change that happened throughout this year, and that we recognize that we need a separate network, sub-network inside the Lightning Network, and it's not just a generalization of existing Lightning Network, it's something that is put next to it, and we call this evolution of the concept of generalized Lightning Network Bifrost.
Got it. Thank you. Okay, moving forward, why is it not possible to keep using a legacy channel with the legacy Lightning connection when you upgrade the channel to Bifrost? What makes it impossible to separate states between legacy and Bifrost transactions?
Well, the collisions, first of all, and the second, the fact that Bifrost allow you to modify the structure of the existing channel such that it will become incompatible to the legacy Lightning Network. And the whole value proposition of Bifrost is to add something to the channel that is not supported by the legacy Lightning Network. That's why if you move channel into Bifrost and will allow it to interact with the legacy Lightning Network, you will get a lot of undefined behavior, and unpredictable behavior and fund loss and channel closes and all of that, which is not desirable at all.
I guess any private would be very nice for Bifrost. What about other possible Bitcoin future soft forks?
Well, I will say that it's not any private will be nice for Bifrost. Bifrost doesn't depend on it, but any private will be nice for L2, and Bifrost is nice for L2 too, because you can implement L2 on top of Bifrost with much less effort than trying to stick it into existing legacy Lightning Network. Once any private soft fork will be out, of course.
Well, RGB is not a soft fork of Bitcoin.
Yeah, it's not a soft fork, neither hard fork or soft fork. It requires no changes to Bitcoin network.
Mm-hmm.
Okay, seems like we are out of questions.
Yeah,
which actually makes me happy.
Thank you very much for the presentation, Maxim. Thank you guys for joining us today.
Thank you for joining us and listening and asking questions.
Yeah, if you have any questions, you know where to send them. Feel free to do that. And talk to you in 2 weeks. Bye, guys. Thank you.
Bye-bye.
Thanks again. See you there. Bye-bye.
Bye.
Thank you. Bye.